We travel back in time to 4.6 billion years ago to see the moment when our solar system was born. Wow, there's nothing that looks like a star or a planet. So far, there's just a giant cloud of dust. It's called a nebula. These are molecules of hydrogen in heavier elements, along with ice, left there from a previous star. But this cloud isn't dense, so it can't turn into a star or a planet. But then a blast wave comes here, maybe even several. There's a supernova explosion a couple of light years away from our nebula. This is when a giant star burns off its fuel, then collapses under its own weight. At this point, a boom of such force that its light can be seen dozens of light years away. The blast wave from a supernova reaches our nebula like a sea wave. It hits the dust cloud, causing it to shrink and become denser. Then the nebula gained a common center of gravity. It attracted more and more dust particles to itself. This put a lot of pressure on the nebula's core. It started spinning. And the greater the mass of the central cloud, the faster it rotated. The particles inside the core collided faster and more frequently. This raised the temperature of the nebula to several thousand degrees. At this point, a protostar appeared. It was a young and unstable sun. When the temperature in the nebula's core reached millions of degrees, nuclear reactions began there. The cores of light elements like hydrogen and helium hit each other and fused into heavier elements. Let there be light. 4.5 billion years ago, the protostar evolved into a stable sun, but 30% dimmer than we have it now. There's also a giant cloud of dust left behind. This is the remnant of material that didn't take part in the creation of our star. Now you can see the larger objects in this cloud. Heavy elements and dust began to pile up, forming protoplanets. At this stage of our solar system's existence, there were about 100 protoplanets, ranging in size from lunar to Martian. Back then, there was nothing but total chaos. These protoplanets didn't have clear orbits, and they began to collide with each other. Some crashed into a pile of debris, creating massive explosions. Others collided tangentially and simply changed their trajectory. In this cosmic billiards game, the largest protoplanets won. They literally ate the smaller debris and got bigger and bigger. The chaos didn't stop until about 100 million years later. You can see some nearly formed planets: Mercury, Venus, Earth, and Mars. Our home planet now looks more like a lump of lava. The constant bombardment of the surface by various asteroids has heated the planet greatly, but now it has begun to cool down. Everything went quite well until an unknown villain appeared on the horizon. It's Theia. It's a hypothetical planet the size of Mars, formed around the same time as the other planets. And now, it's spiraling toward Earth, ready to hit it. Bam! As a result of the impact, a huge chunk of our planet was knocked out into space. Theia herself was blown to pieces. Its core merged with the core of the Earth, while the rest of the material remained in our planet's orbit. Gradually, the debris from both planets began to collide with each other and merge into a large cosmic body. When the dust settled, the Earth received its satellite, the Moon. Another hypothesis for the formation of the Moon suggests that Theia was much larger than Earth. It only lightly scratched our planet and continued moving without losing its material. And the Moon was formed almost entirely from particles of our planet. As proof of this hypothesis, we have samples of lunar soil delivered by the astronauts of the Apollo mission. It turns out that the lunar soil is very similar in composition to Earth's crust, and it could only have gotten there as a result of some violent event. Gas giants like Jupiter, Saturn, Uranus, and Neptune formed a little later and further from the Sun. These planets are literally balls of gas. There's no solid surface. If you step on Jupiter, you'll fall until you reach its core. These guys couldn't get a solid surface for several reasons. They formed later when other planets took over the metals and silicates. They also all originated beyond the frost line. This is a hypothetical point somewhere beyond the orbit of Mars. The sun doesn't heat the area behind this line enough for water to be in a liquid state. So there was a tremendous amount of ice in the remaining clouds of gas. 3 million years after the birth of the sun, these building materials started to pile up and build mass, becoming proto-Jupiter. Within a couple of million years, this ball of ice could reach a mass about 50 times larger than Earth. And the heavier it got, the more gas from the disk it was able to accumulate. In a short period of time, Jupiter absorbed almost all the material from the disk of gas near it and accumulated about 318 Earth masses. Jupiter had a very strong gravitational field, and it wreaked havoc on all objects in the area between Mars and Jupiter. Protoplanets collided there much more often, causing them to collapse. As a result, we have the asteroid belt. These are fragments unable to reassemble into a full planet because of the intense gravity of the gas giant. Saturn, the next of the 4 gas giants. It's 3 times smaller than Jupiter. It's thought to be so small because it's even farther from the Sun, about 10 Earth-Sun distances. And it began its formation even later when Jupiter left almost nothing of the gas disk. But Saturn got another distinguishing feature: the rings. They're so wide that you could fit 21 Earth planets on them, and they're as thick as a 5-story building. We still don't know how they were formed, but there's 2 main hypotheses. So Saturn has 82 moons discovered so far. There may have been one more, but it was destroyed in a wild collision. The moon was shattered into small fragments that began to orbit the gas giant. These fragments, in turn, collided with each other and shattered again. Gradually, debris the size of a skyscraper turned into small grains of sand. Yep, Saturn's rings are made up of cosmic dust and ice. Then come Uranus and Neptune. They are much smaller, only 14 and 17 Earth masses. It is believed that they couldn't reach the size and weight of Jupiter because of the strong solar wind. It gradually blew the gas disk outside the solar system into interstellar space. So there were much fewer building materials for new planets. When Uranus was formed, it experienced a catastrophic collision with another protoplanet, and probably a very large one. The collision caused Uranus to fall on its side. All planets have their axis of rotation pointing upward, but the axis of Uranus is pointing toward the Sun, so it looks more like a rolling ball. Only it's rotating retrograde. That means it's spinning against its own motion. It's like a car driving forward, but its wheels spinning counterclockwise. Behind the gas giants is the Kuiper Belt. This is the area beyond the orbit of Neptune. This is where the asteroids, dust, and ice were left after the solar system formation. It's similar to the asteroid belt between Mars and Jupiter, but it's about 100 times heavier. Knowing how our solar system was formed, let's see how it might be destroyed. The Sun has a lifespan, just like any other star. Right now, it's about halfway through its life cycle. Every second, the Sun turns 4 million tons of matter into solar radiation. Gradually, it'll run out of fuel and begin to burn heavier elements within it. This will increase the temperature, luminosity, and size of the star. In 1.1 billion years, the Sun will be 11% brighter than it is now. The seas and oceans on Earth will begin to evaporate, and our planet will heat up more and more. In 3.5 billion years, its brightness will be 40% higher than it is now. Conditions on Earth at that point will be similar to what we have on Venus now. Life will be simply impossible. In 7.8 billion years, the Sun will start burning hydrogen in its shell. This will cause it to expand and become a red giant. It'll be about 256 times larger. At that point, the star's outer shell will be exactly where the Earth's orbit is now, but it'll lose its mass. So there's a possibility that our planet will migrate a little further away from it. But it won't matter, because life on Earth won't be able to exist for several billion years already because of the high temperature, and a strong solar wind will simply blow our atmosphere away. Then the thermal pulsations inside the star will tear off the outer shell of the Sun. This shell will turn into a planetary nebula, almost exactly like what we saw at the beginning. And all that will be left of the Sun is a white dwarf, the size of the Earth, which will fade away for a few billion years.
Okay, so let's assume this teeny-weeny grain of sand, just about 0.1 inches in diameter, is our home planet Earth. Trust me, we're not even that big on a cosmic scale, so I'm flattering us a lot. You'll see. Anyway, the moon will be just about here, a little over 2 inches away, and we'll have to find a grain of sand that's 3 times smaller than the first one. It's hard to say if this is the one, so let's again assume it is. Now, what's the closest neighbor to Earth apart from the moon? That's right, Venus. It's called our sister planet, because it's roughly the same size and mass. So this here grain of sand is gonna be it. As for the distance, we'll have to take a little walk now. And there we go, over 20 feet away from the grain that is the Earth. And that's at its closest, mind you. Next comes Mercury, and it's more than twice as small as the Earth. So let's take a grain of salt this time for variety. How far do you think it is from its neighbor, Venus? Not even close. It's here, almost 26 feet away. If you've ever seen a London double-decker bus, it's just short of that vehicle's length. Okay, Mercury is the closest planet to the Sun, so naturally, here goes. The big and mighty star, measuring as huge as this rock. It's roughly 8 inches in diameter, so it fits. Now, where should I place it? Well, you'd better take another double-decker, and then some, because the Sun's distance from Mercury is 30 feet, even further than Venus. And a walk from here to Earth is quite a trip already. All in all, the distance is just short of that between 2 baseball bases. Cool, huh? But we've only just begun. Moving away from the Sun, next comes Mars, which is twice as small as the Earth. Let it be a red pepper grain this time. The distance to it, though, is even greater than from Mercury to the Sun, over 33 feet. So, we'll place it here. And now, prepare for the real thing. We're crossing the asteroid belt to reach Jupiter. To do that, we'll need to travel about 275 feet. That's almost the height of the Statue of Liberty. And the planet itself is about the size of this grape, just shy of 1 inch. Now, let's take a smaller grape and fly another 330 feet. That's how far Saturn is from Jupiter. Can you still see our rock? Sun, from here? I don't think I can. Now, if you take the Golden Gate Bridge in California and decide to rise from its lowest to highest point, that would be the distance from Saturn to Uranus, the 7th planet in the solar system. Notice how distances grow larger every time? That's far from over, though. Meet Neptune, Uranus's brother planet. Although they're neighbors, it'll take us another 820 feet to get to it. Put 5 Olympic-sized pools in a line, and you'll get the scale. The former Planet 9, Pluto, is our next destination. If we go straight from the Sun, it'll be yet another 4 Olympic pools away, and the size of it is only a speck of ground pepper. Pluto is 6 times smaller than the Earth. And now comes the barely imaginable. Let's first go back to our Sun and start the journey from there. Remember how far that is? Right, more than a half a mile away now. To get to the inner boundary of the solar system from this point, we'll have to travel around the whole planet 4 times. Yep, we're still on the scale where the Sun is just an 8-inch rock. And when it's done, we'll find ourselves in a humongous belt of floating chunks of ice, the Oort cloud. The width of this belt is way beyond our planet's limits, but we'll try. Let's take 3 rocks of the same size as our Sun here and lay them in a line. And now, imagine each of these rocks is the size of the real Sun. That's the width of the Oort cloud for you, which goes in a circle around the whole solar system. If we put it to our initial scale, the Sun won't be even visible, no bigger than an atom. So let's scrap it now and start over, shall we? Okay, now this ring of stones contains within it the unfathomable volume of space. Its radius is roughly 1 light year, or 0.4 inches now, and that would be our ground zero for all the following discoveries. The closest star system from here is Alpha Centauri, and it will be about 1.5 inches away. It consists of 3 stars and at least 1 planet that could be inhabitable. The system is too small to see on this scale, but we'll pretend this grain of sand is adequate and proceed further. Next, we go to the edge of the Milky Way galaxy, our home. The galaxy itself is about 100,000 light years across, but we're not far from its very center, so the journey will only take us 50,000 light years. On the super shrunken scale we've created here, it will be 1,650 feet. If you lay down the CN Tower in Toronto, it'll only be a few dozen feet longer. From here, the nearest galaxy to us is the Andromeda. In some distant future, it'll collide with the Milky Way. But right now, to get there, we'll need to travel nearly 15 miles. That's 2.5 million light-years in normal count. If you're interested, it's also 2.5 depths of the deepest point in the Mariana Trench, known as the Challenger Deep. Next up is an object we could finally place on a larger scale. NGC 604, a star nebula located in the Triangulum Galaxy. If it were in a single line, we'd only need to travel 1.2 miles from where we are now, so let's do it. And the nebula itself is about 1,500 light-years in diameter, which is equivalent to 50 feet. That's like a 5-story building. But let's get back about half a mile and look at something else. This object is almost exactly the size of a Boeing 747, and surprisingly, it's a galaxy. A dwarf galaxy, to be precise. Messier 32 is 6,500 light-years across and is a satellite to the Andromeda Galaxy. They move together, Messier being tugged along by the gravity of its big sister. And now, I'm going to take you for a ride of your life. Get ready, we're going into distances and sizes that would seem impossible if they weren't true. Let's first get back to the circle of rocks that is our solar system. Moving up and away from our star system, we can see the Milky Way galaxy, spanning 0.6 miles wide. Shooting upward still, we see the great emptiness around the galaxy that we've already crossed today. 15 miles of nothingness. Then, we see the galaxies and dwarf galaxies surrounding ours. First, the Andromeda, then others, until we're high enough to see the whole local group. It's a galactic cluster in which the Milky Way is no more than 1%. The diameter is 62 miles. But higher still we rise, and now we're looking at a bright and shiny Laniakea supercluster, which is home to the local group. From here, our galaxy isn't even visible. The diameter of the supercluster is about 3,200 miles. It's more than the distance from Los Angeles to New York. And even that's not all. Higher and higher until we see the Boss Great Wall. It's a supercluster located unimaginably far from us. And on our current scale, its diameter is about 6,200 miles. That's longer than the Great Wall of China, with all of its branches. No wonder it's the boss. And finally, we're up in outer space now. Even though the model of our whole galaxy stayed so far below, you can't see it without a telescope. And we're now looking at the largest object in the observable universe, the Hercules Corona Borealis Great Wall. On the current scale, it's as far as 62,100 miles away from Earth, or a quarter of the distance to the Moon. And its diameter is the same, so it takes up another quarter of the way. There are trillions upon trillions of galaxies, nebulas, and stars, and nearly infinite possibilities out there. And yet, the universe is always expanding, so it's also only the beginning.
TRES 2b, or not to be, is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here it's pitch dark and scorching hot. TRES 2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. Lovely. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather the first because it's closest to the star, is different in a most horrible way. 55 Cancri e is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star on one side, and between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. That's a getaway spot. HD 189377b, I'm not going to say that again, is the only exoplanet in the orbit of its star, and at first glance it looks quite pretty, blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. Well, for comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. Better duck. The next system, whose name I won't even try to pronounce, this one, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular. It's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely. Kepler-70, hey, I can say that one, is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler-70b, and it still exists, but the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our Sun. It was lucky to survive spending time inside the star, but it's evaporating now and will probably be no more in the near future. WASP-12b is one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planets consisting mostly of gas, result in the star slowly devouring its protege. So pal, what's eating you? My mother. WASP-12b has already taken the form of an egg, stretched toward its merciless sun, and it's unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. Hey, you asked. If you ever wondered what it's like to walk on ice and hot coals at the same time, Gliese 436b is a planet that would give you a vivid example. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven, and yet it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. No list of frightening worlds could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours, and those clouds I mentioned are not made of water but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave, or crazy, enough to try to pass through these clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. Here we have a very long name for a very, very cold planet. Although the host star is not too far away, it's a small and rather cool red dwarf, whose light and heat barely even reach the planet. The temperatures out there fall as low as minus 370 degrees, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice that never thaws. I thought I thaw that thumbworth. Still, if it has a rocky core, it might generate some heat, so there's a chance that deep below the frozen surface, some unknown alien things might lurk. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1,800 degrees, perpetually blown over with winds reaching 600 miles per hour. And that's winter. Well, actually, I don't know that. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when those cool down, they fall on the surface in the infernal rain of molten iron. That'll test your mettle. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot, where anything that could burn will. It's also responsible for a very short orbit of the planet around the star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. Vacation? Nah, let's keep looking. Karat Exo 3b is neither as hot nor as cold as some of the others on this list, but it's terrifying in its own more insidious way. It's a gas giant similar in size to Jupiter, yet 20 times denser. This makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. Karat 7b is another oven-like world. Its day-to-day temperature is over 4,000 degrees. Combined with the rocky surface, it presents an infernal landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Karat 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core.